Exam 1 review, Spring 23, Part 4. Question number 14 says, given a right triangle with B equals 40 degrees and A is equal to 17, find the missing angles and sides of the triangle ABC. And in this case, we need to use a calculator. So I'm going to sketch the triangle. We know that the triangle is a right triangle. And we know to name A, B, and then the C has to be the right angle. We have side A opposite to A, which is equal to 17. And then we have the angle B, which is 40 degrees. And we need to find all of the missing angles and the missing sides. So angle C is 90 degrees. We know that because it's a right angle. Angle A is equal to 90 minus 40, which is 50 degrees, or you could say 180 minus 90 degrees minus 40 degrees, which is going to give you 50 degrees. So angle A is 50 degrees, and now we need to find side C. This is side C, which is the hypotenuse, and this is side B, which is the opposite to angle B. So side C, we can say, using what we have, this is 50 degrees. We have the opposite to 50 degrees, and we can use the adjacent here. The missing is the adjacent. We have two knowns and one missing, so we can find C. We're going to say here that opposite over hypotenuse is sine. So sine 50 degrees is equal to opposite, which is 17, over hypotenuse, which is C. Now, in order to solve that, we know we can interchange both of these, meaning we're going to switch the places. So C is equal to 17 over sine 50 degrees. Make sure your calculator is in degree mode before you proceed. So change the mode to degree mode, and then you can say 17 divided by sine 50 degrees, and that is going to give you approximately 22.19. So that is 22.19 is the hypotenuse. And finally, you can use the angle 40 because B is opposite to it. And then we know the hypotenuse, so we can use the hypotenuse. So we're going to use the angle 40. To me, using the trig ratios is simpler than using the Pythagorean theorem, to be honest. So I'm going to go with that. So I'm going to say here, relation between B and C and 40. I know that sine the angle B, which is 40 degrees, is opposite over hypotenuse. So I'm going to say sine 40 degrees is equal to the opposite B over the hypotenuse, which is, we computed 22.19. Now we need to solve for B. So we're going to multiply both sides by 22.19 to remove it from the denominator. These will cancel. We have B equals 22.19 times sine 40 degrees. So again, make sure you are working in degree mode.
Sine 40 degrees.
And the answer is approximately 14.26. B is 14.26 approximately. And this is how you answer question number 14. Question number 15, again, for this question, you will need a calculator, so you're not going to be able to compute this using no calculator, so calculator is required. A woman is standing 450 feet away from a 1697-foot building. If she looks at the top of the building, at what angle above horizontal is she looking? So now I'm going to...
So here's a woman standing at 450 feet away from a tall building. The height of this building is 1697 feet. If she's looking at the top of the building, at what angle is she looking?
So we need to find theta here. By what we have adjacent and we have opposite regarding to theta. So like relative to theta, these sides are opposite and adjacent, which then we can say that opposite over adjacent is the tangent. So we're going to say tangent theta is equal to the opposite over adjacent, which means to find theta, we're going to take the inverse tangent for both sides of the equation. So we're going to say inverse tangent of tangent theta equals inverse tangent of 1697 over 450. These will cancel. We have theta equals, we're going to revert to degrees because the answer is required in degrees. So we're going to say
inverse tangent of 1697 divided by 450
is equal to approximately 75.1. We're going to round to one decimal. So 75.1 degrees. So that is the angle of elevation. So this is the answer here is 75.1 degrees. A board worker is looking down at her from the 5th floor. So here is the 5th floor in that building. Let's assume it's right there. And looks down at the woman from 553 above her. So this distance right here is 553 feet above her. At what angle is he looking down at her? Round your answer to the nearest 10th degree. So we need to find the angle of depression. So here is how this person is looking at the woman. And in this case, we're going to say that the height of the woman is insignificant because we don't want to say the woman is like 5 feet, maybe 6 inches or something like that. So we're going to say it's insignificant compared to the height of the building. So we're going to ignore the height of the woman completely. Now we need the angle of depression, which is basically this angle right here. I'm going to call this beta. And if you look at this angle, it is the same as this angle right here. So this angle is beta as well. What we know about the triangle formed, this triangle right here, we know the adjacent and we know the opposite to the angle beta. So that is what we're going to say. We're going to say tangent angle beta is equal to the opposite, which is 553, over the adjacent, which is 450. Again, we're going to take the inverse tangent for both sides of the equation. We have beta is equal to inverse tangent of 553 over 450. And we're going to punch that into the calculator. So inverse tangent of 553 divided by 450. And that is going to give me 50.9. 50.9. So this is approximately 50.9 degrees. So the second angle is 50.9 degrees. Hopefully that was clear. Question number 16. The ladder leans against the building so that the angle made with the horizontal is 10 degrees. So this angle right here is 10 degrees. Round your answer to the 10th place and we're going to answer the following questions. So we need the length of the ladder. The first question, find how long is the ladder. Notice how we have a right triangle here. That is the ladder that I just highlighted green. And then the rest of the triangle is the yellow one that I just highlighted. In that triangle, we have an angle and we have the adjacent to the angle. And we need the hypotenuse. Adjacent over hypotenuse is cosine. So we're going to say cosine, the given angle 10 degrees is equal to adjacent 60 degrees over the hypotenuse y. Now we're going to solve. So if it's in the denominator, we can exchange them. So we say y equals 60 over cosine 10 degrees. And we're going to punch that into our calculator. Make sure you are working in degree mode. In this case, 60 is 10 degrees is given in degree mode. So make sure you are working in degree mode before you proceed. And we get the length of y is 60.9. I'm going to round it to one decimal place, just like it says here, 10th place. So 60.9, and the measure is in feet, because the measure here is in feet. Okay, so this is 60.9 feet is the length of the ladder. So here is my first answer. Now we need to find how high does the ladder reach up the side of the building. Notice how they give us the height of the truck, which is the height of the ladder, which is about 8 feet from the ground. So in order to find the total height of the ladder, we're going to find this side, which is I'm going to call this is A, and then we're going to add the 8 feet to the height A to find the total height. So relative to the angle 10 degrees and the hypotenuse we found, A is the opposite to 10 degrees. So we're going to say sine 10 degrees is equal to opposite over hypotenuse, 60.9. Now we're going to solve for A, which means we need to multiply both sides by 60.9. And we have A is equal to 60.9 times sine 10 degrees. Again, make sure you are in degree mode. And we get about 10.6. So A is equal to 10.6 feet. The total height that we need for this question is basically 10.6 plus 8, which will give me 18.6 feet. So that is the answer for the second part. For the first part, let me write it here. We figured that out and it was 60.9 feet. For question number 17. For question number 17, you're not going to need a calculator. The blades of a wind turbine are 125 feet long. The propeller rotates at 12 revolutions per minute. We need to find the angular speed of the propeller in radians per minute. So what do we have? We have the propeller rotates at 12 revolutions per minute, and we need to convert that into radians per minute. So looking at this turbine, the wind turbine here, let me just try to sketch it. It's gonna form a circle basically. And let's say here is the center and here are the blades of the wind turbine. They're going to form a circle anyways. The length of the blade, which is the radius, basically the radius is equal to 125 feet. So in order to find the length of the revolution of this blade in radians, we know that one revolution, we put the revolution in the denominator since we need to cancel it. The revolution's here, so we put the revolution in the denominator. We need it in radians, so we're going to say one revolution. We know that one full revolution is 2 pi radians, so we're going to say it's equivalent to 2 pi radians. One revolution is going to cancel with one revolution. 12 times 2 is 24 pi radians per minute. So I'm going to say the answer is 24 pi radians per minute. So if you do that, if you want to double check your answer, you can basically multiply that, which is if you do it with the calculator, it's going to give you 75.4. Approximately, of course, but we need it as a full answer like that one, usually. We need to find the linear speed of the tips of the blades in feet per second. So now we have the 12 revolutions per minute. We have the speed, the angular speed was 12 revolutions per minute. We need to convert one revolution. We need to compute how many feet is one revolution. One revolution is basically the circumference of the circle the blades are making. And we can find the circumference of that circle because we have the radius. We know the circumference of the circle is 2 pi r, which means 2 pi times r, which is 125 in this case. One revolution is going to cancel with one revolution. And then we have 2 times 12 times 125, 12 times 2 times 125 is 3,000. So this is going to be 3,000 pi. Don't forget the pi. And this is feet per minute. But here it says convert to seconds. So we know that 1 minute is equivalent to 60 seconds, which means we're going to divide by 60. 1 0 cancels with 1 0. If you divide here by 60, by 6 you get 1. Divide by 6 here, you get 5, 0, 50. So it's 50 pi feet per second. 50 pi feet per second. And it's given here. Feet per second. It's given here. Now, if you convert that into decimals, the answer is 157.1. So this is approximately 157.1. Usually what I ask for is the exact answer, because those numbers are not very hard to deal with. Question number 18. The reference angle for 226. 226 happens to be in the third quadrant. So it's in the third quadrant approximately here. This is 226. This is all 226. So we need the reference angle, which is basically only that distance. So if we take 226 minus 180 degrees, then we're gonna get 46, which is our reference angle. So 46 is our reference angle. 350, it happens to be in the fourth quadrant. So this is, let me actually remove that. This is 350. So all of this is 350. Our reference angle is going to be this much, which is what completes it to 360, and that is 10 degrees. Finally, we need to find negative 123. Negative 123 is in the third quadrant. This is 123 approximately, negative 123 degrees. So to find the reference angle, we will need to find that much of an angle, which means if we say plus 180, if we take 180 and then minus 123 degrees, it's negative anyway, so that is the negative here. And that is going to give us the answer, which is 57. Question number 19. The reference angle for 12 pi over 5. In order to find the reference angle, we're going to subtract 2 pi from that. So if we have 12 pi over 5 minus 2 pi, this is going to give me 12 pi over 5. We need a similar denominator, so we know we're going to divide by 5 and multiply by 5. So minus 10 pi over 5, that is going to give me 2 pi over 5. Reference angle for 10 pi over 7, same process that we're going to do here. Okay, so we're going to say 10 pi over 7 is less than 2 pi. We know because 2 pi, let me show you. So if we say 10 pi over 7 minus 2 pi, this is going to turn into 10 pi over 7 minus, we need the 7 here, so we need to multiply by 7, 14 pi over 7. Notice how this is bigger. So since this is less than 2 pi, it's less than 2 pi, we need to do 2 pi minus 10 pi over 7. So 2 pi, which is going to be 14 pi over 7, minus 10 pi over 7 equals 4 pi over. Now, 4 pi over 7 is not an acute angle like the first one. The first one was an acute angle, so the reference angle is the same as the acute angle. Now 4 pi over 7 happens to be in the second quadrant. This is 4 pi over 7. So to find the reference angle, we're going to find this much. Since this is in radians, we're going to say pi minus 4 pi over 7. And that is going to give me, so we're going to say pi minus 4 pi over 7. It's going to give me the reference angle, this angle right here. That is the process. We need this common denominator, so I'm going to multiply by 7, divide by 7. So I have 7 pi minus 4 pi is 3 pi over 7. And that is the reference angle. So this is 3 pi over 7. While for the first one, this is bigger than 2 pi over, this is bigger than 2 pi, because I know 2 pi, if you have a common denominator, it's going to turn into 10 pi over 5, which is less than 12 pi over 5. So that is what we did here. And then the answer, when we checked the answer was in the first quadrant. So we didn't need to do the second step here, which is taking 1 pi and subtracting the angle from it. We know that the reference angle of an acute angle is the same angle. It doesn't change. So that is how you're going to compute the reference angle in radians. Question number 20, we need to draw the angle 60 degrees. The angle 60 degrees, notice how we have those dots right here. We know the first dot is for 30 degrees, the second dot is for 45 degrees, and the third one is for 60 degrees. So 60-degree angle is going to be this one. And don't forget to put the arrow there. Don't forget to put the arrow there, indicating that it's positive. 120 degrees. 120 degrees is basically it's basically 60 degrees shy from 120. And we know this is basically 30 degrees, and this is 45 degrees, and this is 60 degrees, and this is 90 degrees, and this is at 30 degrees, you get 120 degrees. So that is 120 degrees. And again, do not forget to put the arrow. That is very important. And then 315. 315, first of all, this is a multiple of 5, so I know it's going to be a multiple of 45 degrees. So I'm just going to focus on 45. This is 45 degrees. This is 90 degrees, which is 45 plus 45. And this is basically 90 plus 45 degrees, which is 135 degrees. And this is 180 degrees. 180 degrees plus 180 degrees plus 45 degrees is going to give me the next angle, which is 225. So this is 225 degrees, and this is 270. And then plus 45 degrees is going to give me 315 degrees. So that is my angle. And don't forget to put the arrow to indicating which direction you went in. Pi over 6. We know pi over 6 is equivalent to 30 degrees. So that is 30 degrees, or pi over 6. Here is the angle. And here is the arrow. I will come back in another video with the rest of page number 10, 20, and 21.